Hey, what's up, everybody? It's Kyle with Simulation Lab here in Brooklyn, New York. Back again with another 3D Studio Max tutorial using TyFlow. Today we're going to be doing something cool with the new Cuda cloth solver that's integrated in the newest version of TyFlow. Um, I found it to be really satisfying and really accurate, so I want to do a tutorial on it. So we're going to be making something like this scene. Go ahead and rewind this. So it has like a really satisfying result when the cloth collisions occur, as opposed to the older way, which the cloth was a little bit more erratic. Um, so there's a lot you can do with the new cloth solver. Um, so let's jump into it. And I guess as a preface to this tutorial, the cloth solver, the new CUDA cloth solver, is um, very computationally intensive on your graphics card. So um, just be sure that you have a CUDA enabled graphics card installed in your machine. Um, Most of the GTX series and the RTX series for the NVIDIA cards will work just fine, depending on the model. Um, it definitely it takes up a lot of resources on your graphics card. So if you have multiple graphics cards installed, you can assign one particular card to do the calculations and have another one just for navigating your model environment and stuff. So we'll maybe take a look at how to set that up. All right, so let's get started. So I'm going to be doing that scene from scratch. So if you don't want to watch the modeling portion, you can feel free to skip ahead a little bit. But yeah, let's jump in. So customize. First thing I usually do is the unit setup. For this, I'm just going to use standard decimal inches. 1 unit equals 1 inch. Cool. And let's go ahead and create the collision bubble first that we saw in the original video here. This bubble thing. So the way I did that was I just created a sphere. Just plop it in here like that. And maybe make it, I don't know, 25. Let's make it, yeah, 25 is fine. 25 inches. And then we'll turn on edge faces and leave segments at 32, I guess. I'm just going to go ahead and turn on my angle snap toggle there. I'm going to rotate this 90 degrees. And I'll go ahead and center this out. Cool. That should work fine. You know what we could probably do is I'm going to reduce the segments down to 28. Toss an edit poly modifier on there. Turn on polygon mode. And I'm just going to grab the sides, these little side pieces here, just like that. And I'm going to go extrude by local normals. Actually, we'll do group normals. And extrude that out just far enough to where, we can always adjust this stuff later, but just far enough to where like it'll extend past the camera frame, the frame of the camera. Cool. And then what I'll do is I'm just going to delete those faces, so we don't need those. Okay. And then from here, I'm just going to toss on a turbo smooth and see how that looks. That's looking okay. I think what we could probably do is maybe like flatten out the edges a little bit here, or maybe just extend them out a little bit. So we'll go in our vertex mode, and maybe I'll just like grab these vertices here, grab these ones here, and we can play with this a little bit. So I can turn my turbo smooth back on, and I can kind of scale this up to give myself a little bit more of curvature where the tube kind of enters. And you can kind of play with that all you want, but I'll just leave it about there for now. Should look cool. And then from here, I'll keep 3 iterations, or 2 iterations, that's fine. We'll toss on a shell modifier. Cool, and about there is images like we have 1 inch is fine. Cool. And now what we could do is like really quickly, depending on what rendering engine you're using, I usually use FStorm for these tutorials because it's really fast. So I'm just going to use FStorm for now and be able to set my camera width to 1080, what I originally used for the original video. We won't mess with any of this stuff but real quick, I'm just going to toss up in my materials. I'm just going to create a really quick glass material. And if you're using V-Ray or Corona or Octane or Redshift or anything else, it's all very standard stuff. Pretty typical setup for a glass material in most of those rendering engines. So I just converted my scene real quick. We don't need that anymore for now. And I'm just going to create this glass material, make the diffuse color black, turn up my reflections. Again, stuff we could tweak later. Maybe make it around 0.85, glossy. Turn my refraction pretty much all the way up for now. And I'm just going to toss it on my glass tube thing here. And that allows us to kind of like see through it. And maybe for now, just as we're working, I'll turn that down just a little bit more so you can see it in the viewport. Cool. So now from here, we could start setting up a few things. First thing I want to do is create a geosphere. That's going to be our little bubble guy. And what I could do is zero him out and maybe pull it back over here. And we can kind of like play with this and see like how big it is. I want it to like basically almost fill the entire width of the tube with a little bit of buffer. And that should be good enough. Turn on edge faces once again. Okay. And I'm going to add like 8 segments to that. And we might have to come back and play with that a little bit more, but regardless, I'll just pull this over here for now. We'll call this bubble ref, our bubble reference. Okay. So what we could do is under create panel, under the helpers, under TyFlow, go ahead and create a Ty icon and set it to be a circle. I'll stick that somewhere in our scene there. Zero him out. I'm going to pull him all the way back over here. And as we're working, we could probably do, I'll just leave it like that. I'll turn off edge faces. And I'm going to rotate this 90 degrees. Stick him pretty much like in the tube. And again, we can like adjust the size of the icon. Even this really doesn't matter. You could make it whatever size you want, really. We're going to be using the center of that. We're going to be using the pivot to birth our bubbles. Cool. Now we have that set up. What I'm going to do now is we could just toss in a TyFlow object in our scene. So under the create panel, TyFlow, let's toss this guy in here. And we're going to open him up. Just so we can see all of our junk. All right. Now what I'm going to do is birth. I'll toss in a birth. We'll just do like birth at 0 for now, and we'll just birth 1 just so we can get stuff working. And we could set this to geometry if you want. And then what you can do is push this out a little bit more. Toss in a shape operator in there. And we're going to select our geosphere reference. And we're going to add selected. Cool. And then now what I could do is hide that guy. So pull up my layers manager and I'll just hide the bubble ref for now. And then I'm going to do a position icon. Toss that up there. And we'll pick our icon. So we got our bubble bird in there, and you can see that it's kind of wonky, so I'm going to do set it to pivot. So now it's perfectly in the middle of the pivot. And then what I'll do is I'll just toss on a force real quick for now. A couple more things we're going to have to set up before we start simming stuff out, but I'm just going to toss in like a gravity at -1. And I think for this force, what we're going to do is do a wind force in the particle X direction, I believe. Yeah. Okay. So we'll do -1 for the particle X. We'll just kind of see how this works. 30. Yeah, so it's going the right way. Direction. What I'm going to do real quick too is I'm going to, under our time configuration, I'm going to set my frame card to be 300 for 10 seconds of animation. And you can make sure that this is set to real time in the playback options. Cool. And that is a lot of strength, but we're going to need that for when we start doing the cloth stuff. So what I'll do now is I'm just going to reset this to, actually I'll just put this back down to like 5 or something, just so we can see what's happening. It's not so fast. Toss on a cloth bind in that guy. We could turn off our display geometry so we just see the cloth. And what we're going to have to do is under our TyFlow settings, there's a couple settings we have to configure. So under our main settings, I'm going to do the time step, I'm going to put this down to 1/6 frame. And under the particle bind solver settings, I'm going to set this to like 20 steps. And then under the Cuda cloth collision solver, we're going to set this to repulse steps to like 5. Set the repulse multiplier to 0.5. Impulse steps will be 5. And let's do 150 on the IZ steps. And that should be all good. And we'll poke around with that a little bit more probably, but I think that should generally work for smooth cloth for this type of simulation. It's kind of what those are the settings that I used originally. So depending on the scale of your scene and the speed of everything, you might have to tweak those settings a little bit. But regardless, under the cloth bind solver in TyFlow, we're going to have to enable the Cuda collision solver. So we will set a couple parameters here. Under the strength setting, real quick, I'm just going to set these both to 0.65, just a little bit more. And then under the Cuda collision solver, where we just set, I'm going to set my thickness to be, we'll leave this, I originally just left this alone, and then the self collision, I'll just turn that on. And we'll leave self thickness turned off for now. Because we don't see the inside of the bubble mesh, the cloth mesh. If you had like say like a fabric or like a, I don't know, some kind of cloth like fabric, like a blanket or something, like a flat sheet, you probably would want to introduce the self thickness, give it a self thickness so you can see it overlapping on itself. But in our case, we don't really need that because it's a closed surface. So, okay, I think that's pretty much all we need for that. We obviously need to make it collide with the glass bulb object. So I'll go ahead and pick the glass bulb object in our collision here. And we'll just leave all the settings default in our collision. We might, what I might do is just reduce the friction a little bit. Actually, I might just remove the friction. We'll see how this looks. So set the friction to be 0. it might slide right through. But if you want to have a little bit of friction, like a little bit of give to it, you can increase the percentage there a little bit. So anyway, now that that's working and set up, obviously what we probably want to do is before I start simming stuff out and checking it out, I'm going to go into modify bindings. I'm going to toss some modify bindings in here and just do set the timing to be continuous. And under modify bindings, I'm going to inflate it a little bit. And let's do like 100 inches for now. I'll kind of see how this starts to look. Obviously, it's already starting to like do something. So if I start to sim this out, it's taking under the account the speed that I put or the force. So it's already forcing it through, and as soon as it gets in there, you can see what it does. So that's kind of cool. So it's already kind of working. But what I did originally is I want the particles to kind of stop in the middle of the bulb, right? So what I'm going to do is quickly model some kind of point. So what you could do is you could use anything. I'll just use a sphere. And I'll stick that in there. And I'll just turn object properties, uncheck renderable, and check display as box, I guess, for now. And I'll go ahead and zero this out. And with it still selected, I'm going to go under modify. I'm going to change it to center attractor center. Right. And what I'm going to do now is make the bubble basically attract toward that. And I can do find target. Actually, I'll stick this above collision. And I'll say under target object, so I still have it selected, so I'll just go add selected. And under velocity, I'll do like 25. And acceleration, I'll do 10. And maybe I'll reduce my force a little bit. Actually, we'll leave it there. And under collision, I might bring up that friction just a little bit to see how it looks. Do 15, 5, something like that. So we'll start to sim this out a little bit. Okay, so it's moving through the tube, and that's cool, but it kind of like jumps and skips. So we want it to like not really do that. So as soon as it gets to the target, then we'll do a couple other things. What I'm going to do is I'll just copy my collision, and I'm going to paste that as an instance. And then I'm going to modify the bindings. You know what I'll do is I'll copy this as well and paste that as an instance. Yeah. And we will change our inflation force to something like 300, like really thick, right? So I want it to continue once it like gets to the center. I'll sim this out real quick. All right, so you can tell it like it flies through there, and the force is still being applied, so it still like wants to like force it through the other side. We want to basically stop the force at a certain point. So what I'm going to do is under my gravity, my force here, where I have the wind force, under timing, I'm going to go set as particle age, and about the time it gets to like that, I think it was at like 30 frames or something like that, or maybe 25 frames, we're going to stop it. Okay, so yeah, it's about like around that like, well, let's say 18 frames. We'll have to tweak all this stuff later, but like 0 to 18 frames maybe. the wind is not going to have an effect anymore. So I sim that out a little bit so you can see what that looks like. So it forces it through and then it goes bloop, and it kind of just like floats around the sphere and it kind of like tries to find the center sphere, the attractor. So that's exactly what we want. So it kind of just like floats around in there, so it forces it through and pauses. So that's cool. And then what we want to do is I'm going to toss in a time test, and maybe like we'll do set this to frame and greater than, let's say 90 frames for now or something. You know what we'll do is let's do like 40 frames, and then we'll hold shift and drag on the X direction, and I'm going to put another attractor at the end here. I'm going to just call this attractor end, right? So I got another attractor end sphere here, right? And so after, let's say like 40 frames or whatever we set this to be, right? I want it to attract toward that sphere. So I'll go ahead and copy this and I'll paste that. And I'll get rid of this one and I'll pick my other attractor end sphere here. Cool. And then what I'm going to do is I'm going to hold control and grab these, and I'll do copy, and I'll just do paste. You know what? I want to keep this as an instance, so I'm going to copy and I'll paste this as an instance. And then what I'm going to do is I'm going to apply another force. We could just copy this one. I'll paste that in, put that above collision here. And under timing, I'm going to just do continuous. And I want it to go in the, I'll apply a little bit of gravity, and I want it to go in the negative X direction. I'm going to continue that. And then for this one, we'll amp up the strength so it really sucks it through. But you know, we'll leave it at 5 for now. We'll just kind of see how this plays out. So I'm going to sim this out real quick. Okay, so when I sim this out, something kind of strange happens. So it kind of goes through the tube here, and then it still does the same thing. It's still like finding that same attractor. So we got to figure out why. Okay, so I'm going to try to set my velocity up pretty high. So do 100 inches for the velocity, and maybe our acceleration will do 20 or something. And I'm going to process one out and see how. Okay, so gets sucked through, it wobbles around the inside, and then around that 40 frame mark it starts trying to get through the other side, but we really got to force it through. So I'm going to increase my wind force pretty high. We'll set the strength to be like 100. Okay, so I played around with this a little bit. I set my strength for my wind to be 200 in the negative X direction, and my find target, I set that to be 200 for velocity. I kept my acceleration at 20, and it seems to work okay. Comes through, and it lingers around the bulb for a second, and gets basically forced through the other side, and we can play with that. With the timing a little bit in a minute here. So from here, what I want to do is I'm probably going to add some more bulb spheres here, and so maybe from like 0 to 90 seconds or something, 90 frames. I mean, I'm going to do 5 balls, right? So that's going to generate basically 1, and I could probably do more than that. Yeah, let's do like maybe 0 to 60. I'll do 8 or something. The trick with this guy is to make sure that they don't overlap right when they get birthed, because there's some strange artifacts that happen when that occurs. So that looks about good there. So they get birthed and they're like pretty close to one another. I could probably like reduce it just a little bit more. Maybe add one more bulb in here, or something maybe like 0 to 50 seconds or something. But regardless, this is gonna work for us. So from here, before I like kind of start to process this thing out, I could probably already determine that I want to adjust my time setting here. So for my time test, once it gets to the center of the center attractor, I want the balls to kind of like fill up that space and kind of like linger there for a while. So I'm probably going to set this, because we already know that it's going to be birthed up to 60 seconds. So around that like 80 60 frames, around that like 80 frame mark is when they'll probably all be in the bulb, um, more or less. So I'm going to set this to be like, let's set it to be 80 for now, and we'll see how it starts to look. Um, yeah, so I'll go ahead and process it out up to like maybe 100 frames. We'll see how. Okay, so looks like it's working pretty well. The ball's kind of like more or less coalesce into the bulb. I want to increase that time test a little bit, and then I'm going to decrease my find target velocity and maybe the force a little bit more too, because it's like it really sucks them through there really fast. So I want them to kind of like linger there a little bit, but for the most part, it's you can see the spheres are really starting to interact now and kind of squish together, which is really the beauty of the new Cuda cloth solver. And even like the interaction when they leave at this like super crazy fast velocity, um, there's still like no uh, collisions, or there's no like intersections happening, which is really nice. Um, Without that CUDA cloth solver, this sort of thing would not be feasible. I mean, it would if you like spent like an entire day processing this, and for me it only took a few seconds or whatever. So um, that is really the beauty of it. So anyway, what I'm going to do is I'm going to set this back to 0, and I'm going to set my, so let's see, let's say about like 100 frames I want this, or maybe like 90 frames I want to start going through. And we'll set this to like 5 variation, and then my find target, set this to like 150 or something, and I'll set my force back down to like 150, and we'll kind of see how that works. And I can even, like, if I wanted to, after they have found the target and the force is no longer applied, I could add like a little bit of like noise into the mix here, which might actually be kind of cool. So maybe I'll just do like 5 for like a little bit of Perlin noise, and we'll kind of just see how that one works out. So I'll sim this out again. Okay, so I simmed this guy out, and we'll kind of just go ahead and take a look at it. And it's looking pretty cool so far. The bubbles are coalescing into the bulb, and then they're still really quickly being like pulled away, so I can definitely adjust the speed of that. Really all that is just like tweaking these settings a little bit further. Like I do have like a little bit of, like, you could tell there's like a little bit of Perlin noise going on inside the bulb, a tiny bit. I can increase that a little bit too, or maybe even put like a vortex, like a vortex force or something in this guy here, to kind of have them spin around if you want to. Um, or you could do as a spin modifier or spin operator in here or something. It really kind of just depends on like what you want this thing to ultimately look like. For me, for my original scene, I think I just basically left this stuff as is, and I just added a little bit more for Perlin noise force, and it got it to look pretty good. So the last thing that we're going to do, I might tweak these settings a little bit more, but the last thing I'm going to do is set up a quick material for this. So okay, so I set up a quick multi-sub-object material, very simple. It has 3 different color balls, and there's just a color, in the diffuse channel, a little bit of reflectivity, and maybe just a tiny bit of glossiness here, you know. Um, change the IR to 2, so give it even more kind of like highlights and reflection. Yeah, so that's basically it. And then I just applied that to my TyFlow object. And then I just stuck a material ID operator in here and set it to random between 1 and 3. And then as these progress, you should see the different colors appear. Okay, so one last thing, I'm just going to drag this over here. We're probably not going to need this stuff for now. We're going to take one more look at this. So the balls, the spheres come through here. It's looking pretty good. And they start to get sucked through. And so we're pretty much ready to render this thing. Of course, you guys could like play with the tweaking the settings of the forces a little bit more to probably get this to be a little bit more smooth looking like my original video. You know, it just takes a bunch of tweaking to get it to look something like that. So, um, yeah. But for now, that's pretty much the extent of this. One last thing that you could do, not saying you have to do this, but what you could do is to kind of smooth it out even further, is you could add like a push modifier and kind of like push them in just like a little bit, give them a little bit more buffer so they're not like touching the inside of the glass, and that's something you could do in the TyFlow settings. Um, and you can even like relax it if you wanted to get it up, get them to be like a little bit smoother if you wanted. Relax. Yeah. So you could tell what happens if I turn on my edge faces. You can see, you know, they relax just like a little bit, and it gets just a tiny bit smoother, which is actually kind of cool, you know. So regardless, this is looking pretty cool. So I have set up, I just brought over some scene stuff from the previous scene, so just some lights and stuff. The lights are just really simple, just like F-Storm lights that I set to about 10. Got a little backdrop playing in here and my camera. So we are currently looking through the camera, and I'll just turn on show safe frames. Yeah. And I can adjust my camera a little bit, and I'll show you kind of what this starts to look like once we render it out. It's pretty much like where, almost like pretty much where I had it in the original scene. Right? And let's process this sucker out and see how it looks. Kernel settings, just real quick, I'll set this light samples to 12, max step to 24, noise threshold to 0.001. And I could do like an environment map. Maybe I'll just like quickly toss one in there. Cool, so I got one set up in here. Spherical environment, I'll set my gamut at 2.2. Nice, and that's referenced here, and that's going to be, I'll put this to like 2 as a multiplier. And yeah, we'll see how this thing starts to look. So I'll just collapse this stuff, interactive render. Let's pop this up and see what it looks like. There we go, it's looking pretty cool. I could definitely like increase the overall brightness of some of these lights probably. My secondary light, maybe put that to like 8. Yeah. Yeah, so that's pretty, that's pretty close to what we had. Again, a lot of just, you know, a lot of basic tweaking and stuff that um, that I did to achieve something like that. You can adjust the materials and stuff, but ultimately that's pretty much pretty much the extent of it. So yeah, I mean, let me know what you guys thought of this tutorial. I'm definitely looking forward to continuing to play with the new Cuda cloth solver a little bit more in the future. Um, it's definitely really fun to play with because it's so like accurate and satisfying. You can achieve some pretty interesting effects with it. But yeah, if you like the tutorial, please hit the like button and subscribe for more. And let me know in the comment section below if you have any questions or ideas for stuff to do with the new Cuda cloth solver, um, or anything else. But yeah, thank you so much for watching, and stay tuned, and we'll talk to you soon. Thanks.